Hi students, one question has been raised and this is NCERT question number 37 which is right before you. The vapor pressure of pure acetone is 741.8 mmHg and vapor pressure of pure chloroform is 632.8 mmHg at 328 Kelvin respectively. Okay, so now assuming that they form ideal solution. What are ideal solution? The solution which obeys Rolle's law. And what is Rolle's law? That I will tell you. Okay, so assuming that they form ideal solution over entire end of composition, the plot of total vapor pressure, partial vapor pressure of chloroform and partial vapor pressure of acetone as a function of mole fraction of acetone. Okay, so these data are given. Okay, the experimental data observed for the different composition of the mixture is given here. Okay, now from this data we have to plot a graph and we have to indicate and find whether it is positive or negative deviation, okay, from the ideal solution. So this is the question. Now when we plot the graph as you are observing here, we get the negative curve. Okay, so the answer is negative deviation. Now I'll explain everything one by one. First of all, you need to understand what are ideal solutions. So as I told you, ideal solution is the solution which obeys Rolle's law. Now the question is, what is Rolle's law? So in order to make you understand the Rolle's law for a solution of volatile liquids, the liquid which can be easily evaporated, okay, so according to Rolle's law, for a solution of volatile liquid, the partial vapor pressure of each component of solution is directly proportional to its mole fraction in the solution. Now I have written partial vapor pressure of each component in the solution. Now you know that in solution, the most simple solution, it has two components. Okay, one is solvent which is greater in amount and another is the solute which is less in amount. Okay, now you see this is container number 1, this is container number 2. Container number 1 contains the solvent and its mole fraction is x1. Okay, you can also represent it with the xa. So the vapor pressure is P1 naught. In container number 1, vapor pressure is P1 naught, and in container 2 the vapor pressure is P2 naught, and the mole fraction of the solute is x2, which can also be represented by xb. Okay, now you know that when we mix solute and solvent 1 and 2, okay, then solution is formed, and we also know that this mole fraction of solvent and mole fraction of solute, we are adding it and total becomes 1. A sum of mole fraction is always equal to 1. Okay, no matter whether it is binary solution or ternary solution or quaternary solution, the combination of mole fraction is always 1. Okay, so this thing is clear. Now I am going to explain you how we plot the graph between these and what is the meaning of these two. Okay, so I just now discussed that all those solutions which obey Rolle's law are called as ideal solutions. Okay, now in ideal solution we plot the graph of vapor pressure against the mole fraction. Okay, now in the given question, the vapor pressure is also given. Vapor pressure for acetone is given and vapor pressure data for the chloroform is also given, and mole fraction of acetone is given. So by making use of this, we have to find whether it will show positive or negative deviation. Okay, now you are not understanding this question because there is some concept gap in the Rolle's law. Okay, so that I am going to explain you. Now what is the meaning of x1 is equal to 1 and x2 is equal to 0? Most of the students find here problem. Okay, now I want you to focus on the container number 1. In container number 1, the mole only solvent is there. Okay, so this is the container number 1 case. Okay, because there is only solvent in container number 1, so the mole fraction is only 1, and mole fraction due to solute is 0 because in container number 1 there is no solute. Okay, so जाहिर सी बात है, the partial vapor pressure of container number 1 will be P1 naught. You see, this is the P1 naught. यहाँ से यहाँ तक जो है ना, ये आप देखिए वेपर प्रेशर का ग्राफ है. So यहाँ से यहाँ तक this is the P1 naught, vapor pressure of solvent. Okay, vapor pressure of solvent या component 1 भी कह सकते हो. But since there is no solute, so vapor pressure due to the x2, okay, is 0. So here you see this is the vapor pressure due to x1 component, yeah, so solvent component, and vapor pressure due to x2 will be 0. x2 की वजह से vapor pressure कुछ भी नहीं है, सारे का सारा vapor pressure is because of component 1. तो इसीलिए ये आ गया आपका P1 naught और ये आ गया P1 naught because of the x1 या solvent, and due to the solute vapor pressure is 0 because solute is not there at all in container number 1. Now I am coming to the case of container number 2. Okay, in container number 2 you see there is only solute is present. Okay, only solute is present. So the mole fraction because of the solute will be 1, and there is no solvent. So the mole fraction of solvent x1, mole fraction of solvent, will be equal to 0. So since there is only solute is there na, so only solute is there na, so the vapor pressure of the solute will be P2 naught. Okay, so this is the P2 naught, and the vapor pressure due to the component 1 या solvent will be equal to 0. You see, x2 की वजह से ये तो P2 है, यहाँ से यहाँ तक का P2 है, लेकिन x1 की वजह से क्या है, 0 है, तो ये आ गया. Now you have component 1, you have component 2, upon mixing it forms solution. Okay, now if you want to find the vapor pressure of solution, then what we will do, we will combine na P1 naught plus P2 naught, so it will become equal to P total. This is what we show in graph here. P total is equal to P1 plus P2. Okay, इसको हमने ऐड कर दिया. Now there are two type of deviation in the Rolle's law. One is positive deviation and another is negative deviation. That you know, if the curve goes downward side na, then this is the negative deviation. Okay, and when curve goes upward side, that is the positive deviation. Okay, that also if you don't understand, you can again call me, then I will again make a separate video on this. So पॉजिटिव डेविएशन है ये P1 ग्रेटर देन P1 नॉट एंड x1 है ना, P2 में ये ग्रेटर देन हो जाता है, और नेगेटिव डेविएशन में ये ऐसा साइन हो जाता है, -1 हो जाता है ना. एंड नाउ द सेम this graphical representation by making use of these three datas, mole fraction of acetone, mole fraction, partial vapor pressure of acetone and chloroform. By making use of these three datas we have to make the graph. Okay, now you see here, this is the vapor pressure, this is the mole fraction of acetone given here. Now you see vapor pressure of acetone, is it increasing or decreasing? Just check, it is increasing na. So now you see this is the vapor pressure of acetone, it is increasing na. Okay, now you see the vapor pressure of partial vapor pressure of chloroform. You see, check, it is decreasing or increasing? It is decreasing, slowly it is decreasing. So here you see, by making use of this data in the graph, we are plotting the graph, so it is decreasing. Chloroform this graph is decreasing because the data is also decreasing. Okay, now P total का हम ग्राफ प्लॉट कर रहे हैं. P total data is also given here, you see, and we are plotting these values in the graph, and we are getting curve like this. So from this downward curve we come to know that this जो mixture है, it shows negative deviation. So this is your answer. Okay, I hope you got it. Thank you.